we're going to do the same thing here we did with cosine and same thing we did with sine. But this one's going to be easier because the derivatives of e to the x are all the same. So we'll start out, anytime we're constructing a power series, we're going to start out by taking derivatives. If I ask you to find the fifth order power series, and what we're going to start doing is we're going to write just the first few terms of it. So I might ask for a fifth order, which means that we're going to write the first 5 terms. So if we're going to write any kind of power series, we're going to start by taking derivatives. So the derivative of x is, the derivative of f is e to the x, and the second derivative is e to the x. And what I would probably do for something like this, maybe even from the very beginning, this would be acceptable to not write either one of those two and just write this. That the nth derivative is e to the x. And this takes care of all derivatives. That would be a safe thing to do here. So we know all the derivatives, but in this formula here, we need to evaluate the derivative at 0 because we're going to center this thing at 0. So for each one of these, we're going to plug 0 in. So if we plug 0 into the function, f of 0 is going to be e to the 0, which is 1. The first derivative evaluated at 0 is going to be e to the 0, which is 1. And again, it would be safe to just do this if you want. The nth derivative evaluated at 0 is going to be 1. Obviously, this right here, what I have written in red here, what I have written in green here, that's only going to work for the exponential function. It's not going to work for sine, cosine, 1 over x, whatever, because those derivatives are not going to be the same on all orders. So now all we really need to do is plug the information that we have here into this formula. And so we'll say that the first term, which is actually going to be the 0th term, we'll put 0 in for k. The function itself evaluated at 0 is 1, so we get 1 on top, divided by 0 factorial, which is 1, times x to the 0, which is 1. So the first term is really just going to be what? Yeah, I'm going to erase all this and I'm going to put a 1 there. Plus. We put 1 in for k. So that means that we're going to take the first derivative at 0. What's the first derivative at 0? 1. So we have 1 on top, divided by 1 factorial times x to the first. So we get this, plus, next one, put 2 in for k. What's the second derivative evaluated at 0? 1. That's getting kind of boring, right? How about on the bottom, what do we get? 2 factorial, and then times x to the second, or x squared. And so what ends up happening is we get this series, and we saw this series in a different context on Friday. What I did is I asked you to find the derivative of this series, and it turns out the derivative of this series is itself, right? So if we take the derivative of this series term by term, we end up getting the same thing, because this constant term drops out. This derivative here is going to be 1. This derivative is going to be x over 1, or x over 1 factorial. This is going to be x squared over 2 factorial, x cubed over 3 factorial. So that was the context that we saw it the other day. What's the general term going to look like here? X to the, yeah, and we can use whatever variable. If we're using this variable here from our sum, we could use k. You could use n. Really, any counting number variable would be acceptable here. Should have a plus in front of that, and so on. And that right there is the power series for e to the x.